is the ability of the pixel to present shades of gray. So if it has an increase in bit depth, then we're able to see more shades of gray. If it has a decreased bit depth, then the reverse would be true. And why wouldn't you want a detector with as many shades of gray as possible? So not everyone has the same needs. Maybe a dental unit wouldn't need all those shades of gray. Maybe an orthopedic doctor doing bone work doesn't need all those shades of gray. You know, so that might be something that would cut down on the cost of the machine if you didn't need that. But of course, in radiology, we are looking at abdomens, looking at lung tissue, wanting to see all those shades of gray. Then we certainly, the more the better. So, and as I said before, chest imaging needs 10 or more, really more, to demonstrate all the information. And that was the biggest problem that we had going to digital. As I said before, all the other imaging modalities went digital and we were still film screen. And that was because all the information on that chest x-ray, as an example, was too much for the storage capabilities of our computers. And so that's what kept us back until that computer issue was taken care of. Now what we're fighting, and you can probably appreciate this, what we're fighting now with digital imaging is and electronic health records. Do you know? Exactly. HIPAA, privacy, hackers, things like that. So that is constantly being worked on. So that's the next biggest thing. So pixel sizes. Now, let me tell you, the matrix, and this gets, sometimes we get confused with this, or maybe it was just me. The matrix does not change size. The detector that we have in this front room, which I think is a design defect, is 16 inch by 16 inches, a square. So what's wrong with that design? What are your cassette sizes that you use?
14 by 17.
14 by 17. So when you do a chest x-ray on a male, as an example, you're not doing chest x-rays. Gosh, dang it.
Lower leg.
Okay, well, yeah, a lower leg as an example, but a lot of times we turn the cassette sideways. Like for a male chest x-ray, we turn it sideways. On females, I tend to put it lengthwise. I think your book says to put it crosswise for everybody. Well, that's 17 inches crosswise. Well, we've lost an inch with this detector. So if you're doing anything in the table with the cassette crosswise, you're not getting a full 17 inches. So I don't know why it's not 17 by 17, as if you had two 14 by 17s, you could go either way. Don't know. So you're going to have to be a little bit more precise in your centering for those sort of things. So anyway, that detector size does not change. So what would change is if the manufacturer determines that you have more pixels or less pixels. So this is the pixel. How would you describe this versus this? The pixel size.
Better detail? Small?
Yeah, this one's better detail. The smaller the pixel, the better detail you have. But we call this an increase in pixels. This is called an increase in pixels because we have more. They'll say 2056 by 2056, or 524 by 5024. You see what I mean? So the higher the number, the more pixels you have. So that's what we mean by increase in pixels. It's really an increase in the number of pixels, not really the pixel size, but that may be how you read it. And so students are always like, well, but these pixels are larger. So increased pixel size means less resolution. No, it doesn't. And that's what I want to clarify right now. This is an increase in pixels, increase in pixel size, meaning not the size of the pixel, but the number. Got it? Yeah, the number. Again, and they come in different sizes, of course. Versus, what did I say? this is an increase in pixel size, right? You get more pixels, okay? This is a smaller size. So
So does this one have the more pixel size compared to the other one?
well, the other one is not digital.
So this-
So I don't know, I'd have to look up the stats on this, I don't know what it is.
That reason that then the cassette is smaller, so with the increasing, even increasing the SID, with the increase of the pixel size, so we can recover. the whole
Well, all
thing.
you're gonna recover is, detail. You're right, detail, but not, we're talking the detector size. I'm talking about positioning purposes. When I talk about the detector size, 16 by 16, when I say you have to be a little bit more precise in your positioning, if you need to, like for your lower, for your femur, you've lost an inch. Whereas that might have been what you needed using, a CR cassette. So that's what I was talking about with that. But the detector size does not change, but this can change based on the manufacturer. There's no button to change that. I can't automatically, today I feel like, this is built in, this is set into the system. I could get a different detector with a different number, but I can't change the same detector. And again, this is, just looking at pictures, and you can't appreciate the difference here because of the projector. Again, the quality of the projector versus, all of that, you may not be able to appreciate, but you can look at your book. And you can imagine the smaller pixel size will give you a more pixelated image. The larger one will look, have better detail and look almost like on regular film. So some other terms, we've used the term resolution, that denotes detail, and a digital term for resolution is spatial frequency. Spatial frequency. So, again, a little bit different terminology that you're not used to. So again, resolution is anywhere from 5 to 8 line pairs per millimeter. As I said before, as you increase the number of pixels, again, go into more pixels, they get smaller and the resolution gets better. Okay. And then it says no DR system can resolve an object that is smaller than the pixel size. So there's where we lose our detail right there. All depends on the pixel size. So here are some image matrix sizes. I was a little off on that, but anyway, the pixel, the larger the size, the better the resolution. And that's what I mean by the size. Again, the detector size does not change. It's just the number of pixels crammed into it. So as you get more pixels, what happens to their physical size of those pixels?
Get smaller.
They get smaller. So hopefully that makes sense, and it's a real easy concept once you realize what we mean by size. And so, again, you can see just a little bit of an area of a radiographic image contains lots of shades of gray. And what do we call that? Showing shades of gray in a system?
Low contrast?
Is, we don't use the word contrast. We're gonna use what word?
Resolution?
Contrast resolution, very good. Okay, the MTF, and then we'll take a break. The MTF, because you'll want to break after this one. Okay, the modular transfer function, the MTF, and that is the ability of the system to display objects accurately of different sizes. So it's basically the ability of the imaging system to resolve detail. Okay, how accurate is it reflecting what you're imaging? Here's what we want. If you have two small objects, well, I'll make them bigger, that are close to each other, on the image receptor, you want them to be imaged separately. And that would be an MTF of 1. However, what happens because of the pixel size, focal spot size, lots of things, these two images will look like, these two small objects will look like one object. Okay? That would be an MTF that is less than 1. So 1 is outstanding, less than that is not. Okay? What does spatial frequency mean?
Resolution?
Resolution. So if you have high resolution, you're able to see small objects, right? If you have a low spatial frequency, a low resolution, you can only see those large objects faithfully. You can't see those small objects faithfully, as I demonstrated here. So this is a picture out of your book that you have to look at. Now, here is a resolution test pattern. Here's another one, and we have 1, 2, 3, 4, 5, 6 patterns up here. This first one, a line, a space, and a line. Are you able to see that clearly?
Mm-hmm.
Okay, it's showing here in your spatial frequency is that it's almost 1. Why it's not a 1, I don't know. I didn't write the book. Okay, but Vashon gave it a 0.99, so it's almost 1. As the spatial frequency increases, these are all the same pattern, 3 lines and 2 spaces. Can you see the 3 lines and the 2 spaces here? No, it says these are. It says 10. It's like 10, you're able to resolve 10 line pairs per millimeter. That doesn't mean there's 10 line pairs per millimeter right here, but this would be like 0.05 line pairs per millimeter, 0.1, etc. Here's 10, and you can't discern any line, a space, and a line. And so the MTF of that is very, very low. Almost, it's not 0, but there is some information there. You see something, so it's not a 0, but here they have it 0.4. So this is, what kind of relationship would you call this? As the spatial frequency increases, what happens to the MTF? It decreases. And doesn't that make sense? If you know what MTF means, it's the ability of a system to image objects faithfully, to actually see objects as they are in the body. Okay. So if you're not able, so the higher the frequency, meaning you're looking at small objects now, the MTF tends to go down. So going back to this slide here, what is the MTF? We're talking about the image to object size in reference to spatial frequency. And so a high spatial frequency, you're able to resolve small objects. The MTF is not going to be 1 on that, more than likely. Okay, so let's take a break. Let's take a 15-minute break.